Okay, so today's session is going to be about building the modular monolith applications using Spring Modulith. And this is our second session organized by Java User Group Gujarat. And I'm really, really excited for today's session. And today's session will be conducted by our very own technical expert, Shiva, who is really, really keen in this particular topic, who is also a developer advocate at JetBrains. And a bit about, before we jump into the session, a bit about ourselves. For those who have joined us for the very first time, introduction about Java User Group Gujarat, who we are. So we are basically one of the jugs which are there in India, and we are a growing community of Java developers. If you are somewhere in the Gujarat and you are not part of it, do join us. You can follow us on our social media, Java JUJ Gujarat, and we are also highly active on LinkedIn. You can connect with us through these channels. And we are basically responsible for bringing all the Java developers and the Java enthusiasts, whether you're a student, if you're like interested into Java, tech stack, then, you should join us. And we are basically bringing everybody together to form a great fostering community. And we will be responsible for conducting regular events, knowledge sharing sessions like today's one. We will be also jumping into offline meetups as well very soon. So yeah, do join us in numbers, and please do support. We definitely are incomplete without your support. A bit about myself. So I'm also one of the community managers of JUJ Gujarat, and I'm also a Java backend engineer with 10 plus years of experience. My name is Vikas Rajput, and I love writing about technical content. I'm also an independent Java consultant. I'm also very, very much passionate about Java technology. And to know more about me, you can also follow me on or join me on, Twitter or in LinkedIn. Below, these are my handles at the rate Vikas Rajputin. And that's about us. Okay, now we can directly jump into the session. So I'll hand over the screen to Shiva, and he can walk us through the today's topic.
Thanks, Vikas. Thank you. Thanks for inviting me and everyone who is spending time on Sunday to learn about Modular Monolith. Thanks for joining. So let me share my screen. Okay. Can you see my screen? Okay, So, as you know, today we are going to talk about building modular monoliths using Spring Modulith, and a little bit about me. As already Vikas mentioned, I'm a developer advocate at JetBrains. I have been blogging for more than a decade now, and a couple of years ago, I started making YouTube videos just to share whatever I learned. And also I am active on Twitter. If you want to reach out to me, that is the quickest option. And I have written a few books. These are some of them. And this is the agenda for today's session. We are going to talk about what are monolithic applications, what are microservices, and what are the challenges with those architectural styles. And then we are going to talk about what is modular monolith and how to build them using Spring Modulith. And again, while building Spring Modulith based applications, how do you identify modules and how do you ensure that they are following good practices? How do you communicate from one module to another? And how do you test each module in an independent way? And finally, we are going to learn how we can generate documentation automatically using Spring Modulith. So this is the overall agenda for today. So first, before jumping into code and everything, first let us get some theoretical understanding of some of these concepts. Then it would make sense. So about monolithic architecture, this is nothing new. We have been building applications following monolithic architecture for a long time, and then we face some challenges. So usually, what is a monolithic architecture and what kind of applications we call monoliths? So basically, when you are building a large-scale system, there can be many features and there can be multiple modules, but ultimately you are going to package all that as a single deployable unit and then you run the application. So that is a typical monolithic application. And somehow along the way, it got a very bad reputation, like especially with the introduction of microservices architecture, people start considering monoliths are bad, which is quite not right. And also, many people think microservices is a solution for monoliths problem, which is also not quite right. And if you think why monolith architecture got the bad reputation, as usually monolith means a big ball of mud, each component is tightly coupled with other things, and it is a bit of trouble dealing with and enhancing the monolith architecture. But the thing is, if you don't take proper care, usually that happens with monolithic applications. And also, when multiple teams working on the same code base, building various features, you need to have a bit of coordination. Otherwise, it is very easy to step on each other's toes and then creating conflicts and like usually merge conflicts and things like that. That is also a common issue with the monolithic applications. But it is not all bad, especially when you think about monolithic architecture. From the deployment point of view, it is a lot simpler compared to microservices. You can have a single pipeline that whenever you commit some code, it can build the application and it can deploy into some environments, and then you can run it. So can compare that to microservices where you need to have multiple pipelines and then each one has their own storage, and then you need to coordinate between those services. So compared to all that, monolith's deployment process is much simpler. But one of the common challenges in monolithic application is you cannot scale a specific submodule, because at the end of the day, you are deploying your whole application as a single deployable unit. So here, let's take an example in a e-commerce application. Most of the times people browse through the catalog of products than compared to how many people actually place orders. So in that case, maybe we think, how about running 20 instances of catalog module? Then maybe order modules can be run in 5 instances. But in a monolithic application, you cannot do that because it's a single deployable. So these are the common problems with monolithic architecture. And so usually this is how you see, let's say when a architect starting an application following monolithic architecture, this is how they can depict, okay, we are going to build this application. Let's take an example of e-commerce application. And we are going to have a catalog module, we are going to have orders module, inventory module, notification, and some common utilities. So this is how you see the picture of a monolithic architecture in the slideshow in the beginning. But down the line, after 2 months, this is how the reality will be. Each module talks to every other module, and each module is tightly coupled to other module APIs. So if you want to change one thing, you need to touch a lot of things. And if you make one change, that could possibly break other module features also. So this is the reality. If you do not take proper care, making an application a big ball of mud is easy with monolithic application. As I mentioned, if you do not take proper care, it is very easy to mess up an application architecture. So then companies try to address those monolithic application problems using microservices architecture. I mean, it is not introduced entirely as a solution for my monolithic architecture problems, but it also try to solve various other things also. But usually, what is microservices? Like when you are building a big application, usually you break down it into subsystems, and then you identify what can be built and run as a independent process, so that each team can focus on one business capability and run it as a separate service. And in the overall picture, each system can communicate with the other dependencies and then achieve the bigger goal. That is the theoretical microservices capabilities. But again, overall, it all needs to coordinate with each other services, and then it needs to achieve the end goal. Again, taking the e-commerce example, you can have all these microservices, catalog service, order service, notification service, and all these things. But at the end of the day, if a user want to browse through the catalog, place an order, and then get it shipped, all of these systems need to coordinate with one another. Either it is a direct call or through eventing, whatever the means may be, it all needs to coordinate. But if you don't properly take care of or designing the microservices architecture, it can become much worse than a distributed ball of mud in the monolithic architecture. It will become distributed big ball of mud, which is even much worse and harder to deal with. But there are advantages also. Like as I already mentioned, if you want to scale one particular submodule, it is very easy to do with the microservices architecture. Like as I already mentioned, more people browse through the catalog. So you can scale up catalog service 10 instances or 20 instances, but you can just run 5 instances of order service. So that is a capability that provides in microservices architecture. And one of the beginner's mistake, I would say, while designing a microservice-based architecture is they think about, okay, let's separate some of the technical capabilities or like that. The problem with that one is it needs to be designed as a self-sufficient. Otherwise, if you just think about some APIs and all those things, you are indirectly coupling two microservices where without another one, first one doesn't work. It always makes an assumption that second service is also available, and then only it is going to work as expected. So that is a common problem. So when we are going with microservices, you need to think about if we design a microservice, is it going to serve as a self-sufficient or not? So that is one of the key thing to remember while building a microservices based one. And also, as much as possible, you need to think processing logic using asynchronous way, because you need to make an assumption that at any point of time, any service can go down. So you need to think to process any business logic as asynchronously as possible. Otherwise, it's going to be like one service is down and all the other services that depend on this service will also cannot function properly. So this is one thing to care. So when we think about microservices, it feels like, okay, most of the problems are being solved. What are the challenges we see in monoliths? Microservices is solving those things. It looks like that. But then just separating out all these subsystems into its own services is kind of, I would say, relatively simpler. But then you need to make all of them work together. That is the challenging part. Like when you are splitting your system into microservices, obviously you are bringing all the distributed computing challenges. So you need to design your system with a failure in mind. At any point of time, any services can go down, or they may respond in a low performant way. Or if something goes wrong, can the support team identify where the thing going wrong? So all these complexities are inherently come into picture when you go with the microservices. But as our industry has one common problem where when a new style of architecture or when a new technology came in, people try to use it. Whether without thinking, do they really have those challenges or not? They jump on the new shiny things and then try to adopt them. And then they slowly realize, okay, there are a lot more challenges we haven't realized. So that is exactly what happened with many companies. Many companies, once the microservices architecture became popular, they jump onto microservices and then they go building thousands of microservices, and then they realize dealing with microservices is not that easy. And especially they don't need or they don't have that kind of a complexity to go for a microservices architecture. But again, they don't want to go back to the monoliths because we already know what kind of problems are there. So what is the solution? So that is where these modular monoliths come into picture, where you kind of take best of both worlds. You take what are the good parts from the monolithic architecture and take some of the ideologies from microservices architecture. So now when we think back, okay, then why we want to go from monoliths to microservice in the first place? So one of the core reason was over the time it is becoming a big ball of mud because there is no proper mechanism to ensure the modularity. Like in the beginning of the project, your architect or your manager or your tech lead will say, okay, these are the modules we are going to build, and this is how we communicate it. In theory, that's how it starts, and it all looks good. But then over the time, when developers are especially working in a tight deadline-driven environments, they kind of okay, let's call this method and get this thing done. Okay, let's publish this and then see if it. So it is easy. Like you start calling repositories, you start calling other services, and it is really hard to control that modularity in a controlled way. So that is the problem to solve. Instead of throwing away the entire monolithic architecture, that is the problem we want to solve. So this modular monolith is betting on that concept of you still go with the monolithic architecture, but this time we want to ensure each module is developed in a strict modular fashion. And finally, we are going to bundle this as a single deployable unit so that you all have the simple deployment process and management of your service. But this time you are going to get the strict modularization. So even though if developers are trying to make some mistake unknowingly, like calling each other service without going through the proper structure, we need to ensure that that is not going to happen. So that is what modular monoliths is trying to achieve. And another reason is when we are building a system, and if we decide to go with a microservices architecture in the beginning itself, that is when we have the least knowledge about the system, how it is going to look like in the 5 years down the line. Because you are just starting, you don't know the boundaries clearly. You can vaguely think, okay, I can divide this into microservice, this into separate microservice, but you really don't know these are the real boundaries, or are we aggressively going ahead and splitting into two micro level? Let me share one example. So a while ago, I have worked on an e-commerce system where in the beginning itself, they divide the application into product service, promotion service, inventory service, catalogs. So they divide this into too many services in the beginning itself. And in the product service, they are maintaining only product information. And then there is a separate promotion service where they are maintaining for each product what are the promotions we have. Okay, for product ID P123, we are giving 10% discount. For product P124, we are giving 5%, something like that. Now, we want to show in the web page all the products information with a descending order of price. So somebody want to browse certain books or some apparels, but they want to see in a descending order of the price. So how can we show it now? Because we have products in one microservice. We have promotions in the other microservice. In order to show the products in the descending order of the price, we need to club and then derive the net price of the each product. So how can we do that without clubbing all of them? We cannot decide whether this product is pricey than the other one without bringing entire data of product service and the promotion service. We cannot decide which product is more costlier than the other. So why it happened? Because we went ahead aggressively and think, okay, promotions can be a separate service. And now imagine how much effort it goes into now if you want to club two different microservices. So it's first of all, separating it itself involves some time and effort, and then you set up all the pipelines and everything. And then you realized we did a mistake. With this architecture, it is almost impossible to just load the entire data of two databases and then merge in memory and then show the products in the descending order of the price. Now, again, you need to spend a lot of time and then clubbing all these things, database migrations. So why it happened? Because you separated the services in the beginning of the project when you have the least amount of knowledge how your system is going to evolve. So instead, you should start small, like maybe in a monolithic application. Just imagine you have a different package for managing promotions. You have a separate package for managing products. Now you just realized, okay, they are not really two completely different one. You can simply match two packages in the same application. It's a lot simpler to realize the mistake and then correct when you are in a monolithic application, right? So these are the kind of things you get to know sometimes in a little bit later, and then there will be a lot of cost associated to it to correct those kind of mistakes. And modular monolith is one of the approach where you can get to know the domain logic and then the kind of challenges you are going to face, and it will be much easier to correct those mistakes. Once you go ahead with the modular monolithic approach, it is a very organic way to approach to microservice, because over the time you build it as a monolithic application and then you understand that, okay, I just want to take this service as a separate microservice for whatever reason. So because you are already building this monolithic modular monolithic application with each package as independently as possible, it is much easier to extract that one sub package into its own microservice. So I would say you start with a modular monolith, and then over the time, if you realize and then if there is a need to take one of the module as a separate microservice, it will be much easier to do than starting with the microservices architecture from day one. And also, different teams can work on different models. Though it is a single code base, each team can work on a separate package, which is nothing but a module. And there will be a lot less stepping on other stuff. It will be comparatively very less challenging. And also, while building modular monolithic applications, as I said, you need to aim for each module should work as independently as possible. But again, it is almost impossible to decide a module should not talk to other modules, because as a whole, it needs to talk to other modules sometimes. So, but you need to aim for reducing that coupling, like as much as possible, you try to make a package, a module as independently as possible. But if you have to talk to other modules, prefer asynchronous event-based communication. If that is not going to fit for your business needs, then as a final approach, you can talk to the API in a synchronous fashion. So these are some of the guidelines you need to aim for while going with the modular monolith architecture. So usually, okay, let's say we have a system which is already being built as a monolithic application, and we want to move it to modular monolith structure. So where do we start? So we can start with, usually many people start with package by layer, where you group the classes or components based on some technicality, like all the controllers, you put it in one package, all the entities, you put it in one package, repository services. So here you see in controllers, you have customer controller, order controller, product controller, like that. This is usually called as package by layer, based on the technical layer thing. But this is the first step you should take if you want to go with the modular monolith stack. Like you package by feature. So here, instead of technical grouping, you go with the feature-based grouping. Like all the code that related to catalog will be in one package. in one package means like right now, just for the demonstration, I put all of them in a single package, but within catalog, if there is too much of code, you can again create sub packages and then organize code. But everything that deals with the catalog will go into this catalog package. In the same way, everything that deals with the customers, you put it in the customers package, same order or inventory. So this is the first step you take to go into this modular monoliths architectural style. So again, this is fine. We can do this, but anybody stops us from calling from product controller to customer service. Let's assume this is a public class. It is a public class means anybody can access it. So people are going to call from product controller to customer service, and order service may call customer service and product service, or for whatever reason, order service may directly try to call product repository. So though you took a good step in the direction of packaging by feature, still you are not preventing the people by coupling into different packages or even circular dependencies. So as long as they are public classes, people start calling them like for whatever reason, let's say for processing an order, they need some customer information. Maybe they need some product information. So they may directly call either customer service or customer repository or product service, product repository. So again, though you try to do the right thing, there is no solid restriction where you prevent the coupling. It may again become like a too much of coupling. This module talks to other modules, internals and everything. But this is a good start, package by feature. This is where modular monolith using Spring Modulith came in, like where it helps you to avoid that mistake, like trying to call internals of other modules. So that is what we are going to look at, how Spring Modulith help us to not to mess up this by calling other modules internals, only access through a public exposed API. So that's what we are going to learn. Okay. Again, through modular monolith, this is how it is recommended. Like try to make each package as independently as possible. And then prefer, if you want to communicate something, prefer publishing events and then let other interested modules consume those events and then process them. But not all the times that is possible. Sometimes you have to directly talk to other modules. So like in this case, order module is talking to catalog module. Maybe sometimes it is necessary. So you can call this one. So overall, this is the goal of going into the modular monolithic architecture. Okay, so that is a kind of a theoretical part. Now let us get into how we are going to build using Spring Modulith, and then let's explore various features, how it prevents becoming our modular monolithic application without becoming like a messy, tangled with each other module. Okay, so now if you are familiar with Spring Boot, you know that you can create a new Spring Boot application from Spring Initializer or directly from the IDE. And typically, let's say you want to build some RESTful API, maybe using Spring Data API with Postgres, whatever, like, okay. And this is where you can add the support for Spring Modulith. Okay, so once you add this one, you have certain default rules. How do you create this, and then what kind of features you get out of the box. So now I have already created an application. Now I'm going to walk you through what are all the features we have in this application and how Spring Modulith is helping us to build this modular monolith. Okay, so anyone has any questions so far before starting this one?
So what is the version
I
with
have.
which this starting, Shiva? Like Monolith support is starting with which version of Spring?
I think Spring Boot 3 supports
Okay,
Modulith.
from 3.8. Okay.
Yeah, now as an example, I am using latest version. I have this sample project using even milestone version, so that maybe if you want to try it out by the time it may release as a final version. So I am using cutting edge milestone 3. But if you want to build Monolith, I think Spring Boot 3 onwards, you can build the application with Spring Moduliths.
Okay.
I have a question. If all of our applications are mainly based out of Kafka applications like Kafka streaming, consumer, so even then, should we try this modular monolith?
Okay, so here when you say Kafka modules, like usually two things happen, right? Like from your application, you may publish data to Kafka, or somebody else publish data to Kafka, and then you are consuming it. Okay, so here, once you consume the data, you need to process it in some way, and you need to structure that code in such a way that only certain parts are accessible by other modules, and some of them are internal to this one. So maybe once we go a little bit of this, then we can talk how it applies to Kafka or any event-driven system also.
Yeah, okay. Thank you.
Sure. So any other questions, or can I start? So this is a sample application, and this is the overall structure. Here we have a catalog module, we have inventory module, orders module, notification module, and all of them are using single database, Postgres database. And also some of the modules process something and then publish events to a event repository, and some of them are consuming and then processing them. So this is a very simple application for the demonstration of it. So now how we are building that, it's a Spring Boot application, and then we are using Spring Modulith to structure it in certain way where each module is as independently as possible, and we are not having any issues like one package is using other packages, other modules, internal implementations, are having circular dependencies. So Spring Boot is helping us to prevent these mistakes. So for example, orders may depend on inventory, and if inventory also depends on orders, like some of the classes may call order package, making a circular dependency. So by using this Spring Modulith, it will prevent all those mistakes. Okay, so how Spring Modulith concept work here? In a typical Spring Boot application, you have a main entry point class which has this main method where with Spring Boot application. So this is the main entry point class for your application, right? So in which package we have that one? In com Siva Labs bookstore. In this package we have that class. So Spring Modulith consider bookstore package as the root package, and inside that root package, every direct package is considered as a module. So here we have a catalog module, common module, config, customers, inventory, notification, orders. These are all the modules, top level modules. This is the root module, and these are all the sub modules. And in each module, we want to put everything that is related to catalog, be it some kind of a configuration, be it a REST API, be it service layer, repository layer, anything, any configuration related to catalog, we should put it in the catalog package. Same for other cases also, like everything related to orders going to this order package, everything related to notifications going to notification package. So that is a common thing. But here, first let us quickly go through what we have in this implementation. Then let us understand how Spring Modulith is helping us here. So directly inside this catalog package, we have a product, which is nothing but a record, a simple data structure with code, name, description, amount, something like that. And then there is a interface here, product service with a couple of methods. and these two are public classes. Okay. So by definition of Spring Modulith, in a module, so each direct packages in the root package is considered as a module, right? So now in the catalog module, any classes that are public directly, not in the sub packages, but in the direct catalog package, all the classes that are public are considered as the public exposed API, which means from other modules, they can use these classes. That is it. It's a module where this is the public API. And anything inside the nested packages are considered as private to this catalog module. Though they are, maybe they could be public classes, but Spring Modulith treats everything in the nested packages by default as private to that module. That means here, let's quickly go over, we have Reddy product record, we have product service interface, and then if you go into a web package, we have product controller, and we have simple couple of API endpoints. Here we are getting a list of products, and then here we are getting a specific product for the given code. So nothing super complex here. And in the domain package, we have a product entity, which is a JPA entity. And then we have product repository, which has few methods to return a list of products and things like that. And then we have product service IMPL, which is nothing but implementing this product service, which is a public API. Okay. And this is the internal implementation of this package. But here, if you notice, this is a public class, which means you can technically, this is a Spring service, and also it's a public one, which means technically in Java, you can inject this into, let's say in address controller or whatever, you can inject. But this is where Spring Modulith came into picture, where it is going to say, no, you cannot call that because that is a private to this catalog module. Only you can access the features of catalog module through the public exposed API. What is the public exposed API? This one. You can access the product, you can access the product service. These are the only two classes that anybody can access about the catalog API. If you try to, just because technically it is possible, if you try to inject product service IMPL, Spring Modulith is going to fail certain tests saying that you are doing something wrong. You are trying to access private part of a catalog module. Okay. So, and also here, some controller advice where if you throw product not found exception, we are creating a problem detail object and then returning 404 error. So this is everything related to catalog is there inside this catalog package, and nobody can access product controller. Obviously, nobody is going to call directly. When you call APIs, these are going to be executed. But here inside the domain package, best thing is making them as package protected, because we do not have any public here. It is not even possible for anybody to directly use the product entity. Only the classes within this same package can access this product entity. So the first thing you need to try to do is restrict the access to the least amount of packages as much as possible. So here, I don't want to expose my JPA entity directly. So if you notice in the product repository, when we call find all by giving a pagination, we are not returning the entities. Instead, we are using this constructor expressions and then building the product, which is nothing but a public record here. So we are building the product and then we are returning it. We are not returning product entities directly. Okay. So then we have implemented this product service interface, and here also technically you can make it as a package protected. You don't need to make it as a public one, because anybody want to use product service, they can inject this interface and Spring will take care of injecting the actual implementation here. You don't need to make this as a public one. Okay, you can make it as a package protected. So it is not even technically possible to access product service IMPL at all. Okay, so this is the core idea of a module using Spring Modulith. Any questions so far? So this is the foundation. So I want to build on top of it. So it is important to understand this module concept here.
Shiva, one question here.
Mhm.
Is it our responsibility to make that product service IMPL as package protected, or Spring Monolith will take care?
No, it is our responsibility. The reason why I have public here is to demonstrate, even though now, okay, let's say it is public class, right? So now if I go to, let's say in order controller, if I want to inject that private final, I can access it technically, right? Because
Yes.
it is a public one. I can access it. But if you make this as a package protected, you cannot.
So that means
here,
sorry to interrupt you. That means this is a core Java feature, right?
yeah, core Java feature.
Then
But
what?
I'm coming to that. So
Okay.
if it is a package protected, then you can't even use that one. So Java itself is preventing you to access that one. Good. That is the approach that could solve the problem. But problem is, if you want to, let's say, for example, in the web, you have some other service or something like that. Okay. If you want to directly access product repository from the product controller itself. Okay. And you put the controller in a different package, web, and you have a product repository in a different package. Now, if you want to inject that one, you need to make this as public one, right?
Yeah.
If you make this as a public one, then anybody else also can inject that. So your intention is only to be able to access this product repository only from within the same module. And because you want to put that in a different package, you need to make it as a public one. But the moment you make this as a public one, it is also accessible from other packages as well.
Got it.
This is where Spring Modulith come into picture. So Spring Modulith will take care of, but it is a public one. Technically, you can inject that into other packages as well. But Spring Modulith will check and then tell you it is not a public exposed API because this is inside a nested package. You are only allowed to access the public API that is directly inside the catalog package. Even though it is a public class, you are not supposed to access from the other packages. That check will be done by Spring Modulith.
Got it.
So now if we remove this.
So Siva, just one more question in line to that only.
Yeah.
So how Spring will understand that this is a different package altogether, that it should not be accessible from the other packages? So is it by the Java modular things or how? Yeah.
Spring, when we generate a project with Spring Modulith, we have this test added, Spring Modulith starter test. Okay, this dependency will be added. Once you have this dependency, you can write a test, modularity test, and you create application modules which contains, this is the starter point of your application, right? Bookstore application. So you create an instance of this modules and you simply write a test, verify modular structure and call module start verify. So this is going to make sure whatever the module structure you have implemented is not violating those, is not violating in the sense, let's say this is a public one, and then we inject that into order controller, then it is going to identify, okay, it is violating this principle. For example, right now, let's again make this as a public one. And right now, we are not violating any of those tests. And if I run this test, it is succeeding. So there is no problem. There is no violation. But now what I do, I try to inject this product service IMPL into order controller. Let's try. Okay. Because technically this is a public one and I try to directly use that one. Okay. So now when I run this modular test, the test failed and it is saying it identified a violation. Module orders depends on catalog. Here order controller depends on product service IMPL. Allowed targets, catalog and customer. Okay, so it is saying you are not allowed to access the internal parts of the catalog module. You are only allowed to access the components that are directly exposed by the catalog API, which is nothing but product and product service. So instead of injecting a product service IMPL, let's inject product service, not product service IMPL. Okay, so here product service is a public exposed API, which is there directly inside the catalog package, which is having public. That means it is accessible. And now I am injecting that into where is order controller. Now I injected that, though I haven't used it anywhere, but technically I injected that. So now if I run the test, it is accepted. It doesn't find any violation because from other module, from orders, you are accessing the publicly exposed API, not the internal parts of the module. Is it clear?
Yep. So we have to be depend on the test, right?
Yes.
For this,
yes.
right? For verification.
Yes.
Yep. Thanks, Siva.
Yeah. So that is in a. So this is the whole point of it. Like modular monolith is not a new concept. This is building a modular application is not at all a new concept. It was there for a very long time, where whenever you are building a complex system, you are going to decouple that into different modules and then you implement that. But what is the difference? Why this is becoming now a mainstream thing is, earlier that is all kind of a developers need to simply understand and rigorously follow that. They need to take care of verifying, okay, am I following this pattern or not? Am I by mistake I am using any internal implementation? Because if you don't have that kind of automated checking, people may accidentally try to inject this one and it works. It doesn't complain because this is a public API and you can inject that and it works fine. Unless manually you go and verify is any developer violating these kind of things, there is no way to find out. But now with the Spring Modulith, it is becoming a automated fashion. Like you simply write one test and then it is doing this automatic verification of are you violating any such modular practices? Are you violating and creating any circular dependencies? So it is doing all that through automated process. You don't have to rely on people understand the concept and then following it. It is automatically catching those errors. By mistake, if somebody tries to violate or by mistake, this is going to catch that mistake and then it will tell you there is some problem happening.
One question here.
Yeah.
So in this Hello World application, looks like you have used only one Maven module or maybe Gradle, whatever, right? But in general, in any given enterprise application, there will be n number of modules, right? So how it's going to work if we have multiple Maven modules?
So it is going to work in the same way. Like right now, it is a single Maven application. But even if you break it down into a parent POM, and then you can use a separate module for catalog, separate module for customers, you can still follow the same pattern.
So that validation will be performed within a specific module or across the modules?
So here, in this case, in a modular monolithic application, finally, you are going to, let's say what happens, you are going to make a separate module for catalog, separate module for customer, separate module for inventory, and they're all kind of a jar type modules, right? Finally, you are going to build one application, which is going to be the main Spring Boot application. And in that application, you are going to add the dependencies of catalog, customers, and everything. So in this application, you are going to write this test. So it is going to take care of, even though technically they are all separate Maven modules, it is going to take care, okay, this is the starting point. And then it will identify whether we are all following this structure or not, whether they are in the same source tree or they are coming from a different package. It is going to perform the same checks.
Got it. And on the package structure, so since it's a default thing, probably it would have recognized a catalog and then config and customers as different modules. But in general, we may have different package structure, different directory structure and all, right? So is it possible for us to let Spring know, saying that, okay, just look at this specific package structure and consider this one as a module? Can we configure?
Yes. So in while defining the application modules, you can specify, suppose you want to ignore, you really don't want to process that checking for, let's say, configuration process, or some modules, some packages you want to ignore that. So you can do that. You can specify which packages you want to consider, which packages you want to ignore. You can do that.
Got it.
Even this is the default, what do you say, discovery process. So when you simply add that Spring Modulith dependency, this is how Spring Modulith is going to discover what are all the modules are there. So if you want to have a customized way of discovering, you can create your own discovery mechanism and then do it. But unless there is a good reason, the defaults are decent enough. Like you can just, usually that is the suggested mechanism. This is the root package, and anything you are putting here should be treated as a separate module. And inside that, you can organize the code in whichever way you want. Okay, inside that, it is up to you. And only you need to take care of is only the public API is exposed. And rest of the things, they are protected. Like only here, public APIs, these are all kind of an internal implementation. But again, if you take any existing applications, maybe this is not the way you structure your current code. Maybe you put this product into some models package, then it will become a private part of the catalog, right? Then how do you expose it? So that is one thing that we are going to check next. Any other questions?
I think I'm good. Thank you, Shiva.
So that is the part. Like here we say, if we are building a greenfield project, this is how I would structure. Like these are the two classes that I want to be part of the public API, and I put it here. But what about, let's say you already have an existing code base and you put this into, let's say, models package, or you put that into a domain package or something like that. And you want to make it accessible by other modules also. For example, if you check in the orders package, we don't have any public package, because this is only exposing the API through REST API endpoints, and nobody is calling this directly, so there is no public API. Only API endpoints are exposed. And from here, it can call domain, and it can call service and everything. That is fine. But along the way, it also will publish an event, this order created event. And this event needs to be processed by notification module. Here in order event handler, it needs to process this order created event. This is a public one, but it is there inside a nested package. It is not there directly under orders package. By default, it is considered as a private part of it. It is not a public one, right? So if you have the code that you want to expose to other modules also, and this is how you can do it. You can create this package info.java, and here you can name this package explicitly. So I just gave this name as order events. So when you make this as a named package, when you have a package info.java file with a named interface, and you can give whatever the name you want, then you are saying this is also a exposed API. Anybody from other packages can access. As long as this is a public one, they can access. Is it clear?
Shiva, one question here.
Yeah.
So this is at the package level, right? Like the package level, we say that this package can be accessed by other classes. So do we have one more event in the class, like order deleted event or something? Will that also be accessible?
Yeah, so here this is at the package level, which means if you have a public order deleted event, that is also can be accessible by other modules. So if you don't want to access, make these accessible by other modules, you can make them as package protected. But again, if you make that, it is not even be accessible by other, even within the same module, you cannot access it.
Thank you.
So if there is a requirement where you have only order created event you want to expose to the other modules, and then there is order delivered event you don't want to expose it, maybe you can put it in a 2 different packages and then only expose give named interface only for the package that you want to expose. For other package, you just don't create this one, which is not going to be accessible by other packages. For example, just to demonstrate this one, if we don't give this name, okay, now if we run the test, so it is going to fail, saying that module inventory depends on non-exposed type order created event within the module orders. So if you don't explicitly give it as a named interface, it is considered as a private package, private to the orders module, and is even though it is a public record, it is not accessible by other modules.
And what is this annotation, externalized?
This I'll come to it later. This is not required for the thing I just explained. This is for if you want to publish these events to external message brokers like Kafka or RabbitMQ. I will come to that part. For now, forget about this one. Just think of it's a plain record.
Got it. Also, Siva, one more question. So I remember there was a library called Arch Unit or something, which could
actually Spring Modulith is built on top of Arch Unit.
Makes sense.
Yeah, so it leverages some of its features, and then it also added a lot more features on top of Arch Unit.
Yeah, I was gonna ask that next question, whether it is using that library.
Yeah, it is based on Arch Unit.
Okay, perfect. Thank you.
Okay, so now we have understood few concepts this is how we can order catalog, and then it is very similar in the sense for customers also. We have public API here, record, and then we have API endpoint and domain and configuration related to it. So these are all the private parts of it, and if anybody wants to leverage customers API, they can only call through customer service. Okay, so it is also same thing. And now coming to the interesting part here. Now here orders API is there. As I mentioned here, by default, let's assume there is no package info.java in orders package. That means it can use any of the other modules. As long as there is no cyclic dependency, it can access other modules. That means from the order module, maybe from controller or service, I can access any APIs like a customer service or catalog service or any public API. I can expose. I can invoke them. But if you want to restrict, I want order service only to talk to customers API or only to talk to catalog API, you can explicitly mention them like this. So here you create this package info Java file, and then you can use this application module annotation and specify allowed dependencies, catalog and customers. So with this, what happens is, let's say in inventory, even though let's create a simple class here. Inventory service. Now let's make it as a service. Okay. Now this is a public class and it's a Spring Bean. Now technically I can inject this inventory service into let's say order controller. Okay, I think internally it has the same name. Let's rename it to something. Inventory provider service, something. Okay, that is injected into order provide service here. Technically, it is possible, but now if you run the test, it is going to fail, saying that slice inventory violation here, dependencies. So if you just go through it, what it is trying to say is you explicitly configured in the orders module that orders module can only depend on catalog and customers. It cannot depend on, it cannot access other APIs, even though technically it is possible. Yeah. So if I make it like, okay, not only them, I can also make inventory, but I think inventory as a dependency. Okay, let us see. I don't know whether it is a circle or not. Yeah, I think there is a circular dependency. Here in inventory handler, we are consuming this order event, which is there in the order create orders module. So yeah, this is another feature I would like to demonstrate here. So let's go ahead and so this you understand, right? Like if you want to explicitly restrict on which other modules your module want to depend on, you can name them. If you don't name them, it can technically access any of the other modules public API. If you want to restrict, you can explicitly mention here. But here, the other feature I want to demonstrate is what happens if it forms a cycle. For example, here in orders package, we have order controller, and in order controller, in the create order logic, we are calling order service start create order. In the order create order method, what we are doing, we are publishing these events. Okay, and it is depending on okay, here we are just publishing this order created event. We are creating this order created event and then we are publishing it. And here in inventory handler, which is there inside the inventory, we are consuming that. So it is kind of a depending on the orders. But now from the inventory module, if you want to inject that, it is going to form a cycle, right? Cycle detected from inventory to orders, orders to inventory. So by mistake, if you make this as a cycle, it is going to catch that violation also, and then tells you in a way you are making this cyclic dependency across the modules. So you can, that is a kind of a bad practice. So you can restrict that, and Spring Modulith is going to catch that automatically. Is it clear?
Yes.
Any other questions on the circular dependencies or explicit configuration? Okay. So next thing is, now let us understand, as I mentioned, okay, fine, like catalog is able to do everything it needs to do independently. It does not depend on other modules. In the same way, customer module, it is doing everything by itself. It is not depending on any other module. Cool. But here, when it comes to orders, it is depending on other modules like catalog and customers. How? Let us see. Here, in our order controller, we have an API endpoint to create a new order, and we are calling this order service.create order. So here what we are doing, we are trying to validate the incoming request here. In the validation, we got some product code, and then we want to validate is the product code is really a valid one or not. So here what we are doing, we are injecting this product service, which is coming from catalog API. So here in catalog API, we have this product service. So technically, orders module is depending on catalog module, and we are using the product service. In a similar way, when you want to get a particular order information for the given order number, first we are getting the order details from order repository, which is stored in the order table. And also we just store customer ID. We don't have entire information about the customer. So we take the customer ID, and then we are using customer service to get the complete information about the customer. And we are using customer service, which is coming from, again, customers module. So here orders module depending on both customers and catalog. And these are the direct dependencies. Customer and catalog are the direct dependencies of orders. In addition to that, when you look at a create order, what we are doing, we are creating an entity, and then we are persisting into orders table, and then we are publishing a order created event. We populate whatever the information we want to publish as part of the order created event, and then we are publishing this. So here, event publisher is nothing but this is a core Spring feature. Like application event publisher is a class from the Spring framework. And if you want to publish an event, you can use this to publish. And you can write a listener where it consumes whatever the object you are publishing, and then they can process it. So this is a core Spring features, not even Spring Boot. It is available in the Spring itself. But then Spring Modulith adds a lot more on top of that core feature. We will get to know. But right now, the point is we are interacting our own service, and then we are publishing an event through event publisher. Okay. So what happens when I call this API endpoint? It is going to save the data, and then it is going to publish it. So now who is going to consume that? Right now, there are two consumers. So in IntelliJ IDEA, if you click on it, it will show there is a consumer in notification service. There is a consumer in inventory service. So now if you go to inventory event handler, so if you take a look at inventory, we have inventory event handler, and which is Here we are using Spring Modulith application module listener, and we are receiving this event. And here we are not doing much. We are just printing, okay, received order created event. And then we are just trying to decrease the stock level. So for so-and-so product, we placed an order, and then we take the quantity. And then we are simply trying to reduce the stock level for that particular product code. So it's just mocking here with a static data. And let's assume what we are processing is not really matter. What matters is when one module publishes, other modules can consume them and then process them. In an indirect way, orders module is publishing events, and inventory and notification events are consuming it, making a indirect event-based dependency. Okay, so here we have this, and then if you take a look at the notifications, we have another event handler. Again, this is consuming it, and then we are simply logging notification service received the order created event. Probably here you send an email to the customer saying that we received your order successfully, we will process it, blah, blah, blah. Okay, so we have two consumers like this. And this is one of the recommendation where you, instead of publishing events, what about you expose an API, and then just like the way you are calling customer service and the product service from order service, why can't we directly call them from order service, right? Technically that is doable, but this is where Spring Modulith recommendation comes into picture. You need to design your modules as independently as possible. So here still an event-based dependency is there, but it is not tightly coupled to the inventory or notification service. From the artist's point of view, it is just publishing an event. It doesn't care about which other modules are consuming those events. Okay, so you can consider now it is less coupled to other packages. Instead, if you have some inventory service and notification service, and then you are calling those methods from the order controller or order service, it is kind of not only depend on customers and catalog modules, it also tightly depends on inventory and notifications. But now with the event based communication, it is not a direct dependency on the inventory and notifications. We publish event and it doesn't care who is going to consume the events. Tomorrow you may have a new module and that is also interested in consuming this and then processing it. They can. This orders module doesn't need to worry about them, right? So this is one of the recommendation where design your modules in such a way that as loosely coupled as possible. Like if you can reduce the coupling through event processing, prefer that. Only depend on other modules if there is no other way. If you can do it in an asynchronous fashion, prefer to go for asynchronous event-based communication.
Shiva, one question.
Yeah.
How does the transaction works here? If the order processing has a transaction wrapped and it's publishing an event and there is an issue down the line, how does that work?
Yeah. So as I mentioned, this event publishing logic from here, this is a class from Spring Framework. It has nothing to do with the Spring Modulith itself. And by default, not with the Spring Modulith, by default, the behavior is, even though you are simply here, you can publish it, and then let's go to event handler. If you are not using this one, if you are using event listener, still when you publish that event, this is going to get invoked. There is no direct coupling, but when you publish that, this is going to get invoked and then it happens, whatever the logic you wrote. Though it looks like a decoupled, but internally, all this logic, not only the logic that is executed in order service, this logic is also executed in the same transaction. That means it is kind of execute entire logic in a synchronous fashion within the same transaction. But the very reason we go for event based approach is we don't want to run the handling logic in the same transaction. I want it to happen in a asynchronous fashion. But with this approach, it is going to happen in a synchronous fashion. So what happened is then they introduced another transaction event listener. So instead of using event listener, you can also use transactional event listener. So what happens when you do this is, when you publish the event from order service, that is the end of that part. I mean, this is going to execute asynchronously. It is not going to execute synchronously. It's an improvement, but still the problem is, if something happens here, if let's assume some exception occurred, this is gone. I mean, the event is consumed, but it is failed, and there is no way to roll back or anything like that. The publishing logic assumes that, okay, I published and I hope it is consumed and processed successfully. But if there is any error, it is going to fail, and the event is already consumed and there is no way to recover from that. Then to solve these issues, that's when Spring Modulith introduces this application module listener. And what are the logic that is being handled? That is going to be handled in a asynchronous fashion. And Spring Modulith provides a mechanism where you can automatically publish whatever the events you are publishing, and it is automatically going to store that event data in a database. Whether if you are using SQL database, or if you are using MongoDB or any NoSQL database, there are modules which take care of automatically storing that event data in the database. And when these handlers executed successfully, it is going to mark, okay, this particular event is successfully processed. Okay, we are going to take a look at that one. So now for that, if you take a look at our configuration class. So this flow is clear, right? Let's go here. We have order controller, and then we call this create order, and we are storing the order information, and then we are publishing this. And then we have two handlers. A notification has order event handler, just logging this order received order created event. And then there is event handler in the inventory. Okay, there are two handlers. Now, if we go to our application properties here, also in our form.xml, there are few dependencies we have. So here I have Spring Modulith starter JDBC, and where is events? So events with AMQP, for now put aside AMQP. When you have this events API, it also provides the ability to store the events information also. So I'll talk about what AMQP does, but right now assume that it transitively pulls Spring Modulith events API. So with this dependency, what happens is, let me start the application. First, let me take a look at Docker. Is it running the containers? No, right now I'm going to start the application. So I am using Docker Compose based setup here. We are using Postgres, we are using RabbitMQ. I'll talk about RabbitMQ later, and also there is Zipkin. So for now, let's focus on it is using Postgres here. And here we are using Flyway database migrations, and I have created different schemas for storing different tables. All the customer related tables will be stored inside the customer schema. Similarly, we have catalog, orders, and events. Okay, and again, we have customer creation script, and then product and orders table. So all of them are stored in a different schemas. So this is one of the recommendation where tomorrow, if you want to split one particular module like customer, you should be able to just take this and also associated all the migration scripts you should be able to start the service as a separate one. So that's why I just wanted to separate the schema into different schemas. I just don't want to put all the tables in a single schema. Okay. So now that we have, there is a configuration where I can configure in which schema I want to store the events information. And also I enable schema initialization enabled equal to true. So what this will do is, it is going to, if you take a look at JDBC. So in the Spring Modulith events JDBC, we have different schemas, like for H2 database, for HSQL, MySQL, PostgreSQL, there is a separate schema. It is going to create this event publication with these fields, and then some indexes are created. Now, when we set schema initialization enabled equal to true, when you start the application, it is going to create that table, and whenever we publish an event, that information will be stored in this table. Okay. Now also I configured the events table, this event publication table, to create inside this events schema. Okay. So now when I connect to the database here, Postgres. So here you can see there are different schemas here, and inside the events table, there is event publication table created. Right now, there is no records here. Okay. Now what I'm going to do, I am going to make the call to this order create order API endpoint, this post API endpoint. So I'm going to use this. So here we have post request to API orders, and this is the payload I am publishing. Now, when I publish it, okay, it created successfully, and this is the new order that is created. This is the HTTP API response. But as part of that logic, we have already seen it is publishing the event also. And because we have enabled storing the events information, now if you go to this event publication, it created all the, when an event is published, automatically that is going to be stored in the table. And then if they are successfully consumed and processed, that information is stored in the completion date. Okay. So even if you just publish it and before the consumer processing it, if it failed, let's say the server is dead, then completion date is still null. And then when you restart the application, because we have set a property here, so here there is a property called republish outstanding events on restart equal to true. That means you published an event that is stored in this table, but before processing the request, it failed. I mean, it failed in the sense server is dead. Then this completion date will be null. And when you restart the service, it is going to take the same event information and republish it, and then let the consumer process it. But right now, if you take a look at the log, here you can see we should have a log here. So here, when we publish, here we have inventory event handler, received order created event, and so on. So, and also notification module also received that event, and it also logged this one. Because these event handlers received that event and processed it successfully, they immediately updated in this table. So this way, even though the application event publisher is a simple Spring framework feature, Spring Modulith extend the capabilities of it so that you don't have to write any custom code. It will automatically take care of serializing the order created event into JSON structure. And then it also maintains a list of consumers, and then it also serializes that into JSON, and it stores when the event is published, and if it is successfully consumed and processed, it update that one. So you don't lose any event, even though if it fails to process, you don't lose that. It will eventually, even if your service goes down, when you restart the service, it is going to consume and process.
One question, Shiva.
Yeah.
Still, do we need any message broker here, or database is acting like a
No, this database is this table is acting as a message broker. So right now we are not using any RabbitMQ, Kafka, nothing. So this is a automatic feature provided by Spring Modulith itself, and we can configure, because I have added this Spring JDBC, Spring Modulith starter JDBC. We are telling we want to store the events in the database table. Let's say if you are interested in storing that events information in a MongoDB, you can add Spring Modulith starter MongoDB, and it is going to store the events information in the MongoDB table. Right now, we are not using any external brokers like Kafka or RabbitMQ, things like that.
Got it. And earlier you were explaining about the transaction management as well, right? How this is
so
helping, like,
with this feature, from the publishing point of view, it stores the information, order information in the table, and it publishes that event, and then it returns some response to the API. So here the job is done. From the publisher point of view, it is done. Now the receivers, like here we have receivers, right? So this is going to run in a transaction. And earlier the problem was, what happens if it fails? What happens if the service goes down before it's successfully processed? That was the problem. Right now, with this annotation, application module listener, this logic is going to run in a transaction. And even if it fails, because we already stored that information in the database, when you restart it, it is going to handle that successfully.
So if you take a step back, if you take, sorry to interrupt. If you take a step back in that order controller or order service, so let's say we have returned the response to the customer saying that, okay, your order is confirmed. And then meanwhile, we have published an event saying that, okay, go ahead and update the inventory. Now, what you're saying is in the inventory handling, let's say if some exception happened, does it gonna roll back the order information or
No, this is going to run in a transaction, a different transaction.
Only this one, got it.
Yeah. So here, what it does is, it is going to ensure that the event is not lost. If just imagine if you are not storing that event information in the database, and then service goes down for whatever reason, you lost that event completely. You can never retrieve that information. That is all in memory, and your service goes down and you completely lost that information forever. But right now with this annotation, first thing is entire logic is going to run in a completely in a asynchronous way, completely decoupled from the order publishing side. And then this information is already stored in the database. So even if the service goes down or something goes wrong, you have that information in the database. So you won't lose the data. You won't lose this order event, whatever the events.
Okay. So Siva, that means before invoking this method, it's gonna save the data, serialize it, and save it into database, and then invoke this method, right?
Exactly.
Okay. So what happens if the application crashes before it could save into database?
So then that becomes like a failure on this side itself. So here, if this, so when it fails to store the event information, then it throws that exception. And on the publishing side itself, you see it is failed.
Okay.
So
So,
again, they are going to retry to place an order again.
okay, got it. So now so with the basic Spring event, it would just check whether Spring has published the event. But with this
Yeah.
module, it will also wait until the data is saved.
Exactly. So it is not losing any data. It is making sure that it is stored in the store, event store successfully. Then only it is considered as publishing is successful.
Okay, then this solution looks foolproof, right? Then why do we need AMQP or like Rabbit, Kafka?
Good question. Good question. That is the next part I'm going to talk about. So this is clear, or any questions? So one another thing is, so far when we see, when we publish the data, it is going to store in this one, and when the listeners successfully process it, it is going to update the completion date, and you can see this. But over the time, it may kind of grow in size where you keep storing all the information. So the default scheme is like completion mode is update. The default mode is update, which means it is going to update the completion date upon successfully processing that event. But if you want to automatically delete, if the event consumer successfully processed that event, if you want to delete that row, you can set this to delete. And as soon as the listener successfully processed it, it is going to delete the entire record instead of updating the completion date. So whichever makes sense, you can just go for that flag. Either you want to use delete mode or you want to use update mode. So that is about the events, event-based communication. Okay. Now, so the question, coming to the question, okay, we are using the database table itself as a message store. Then what is the point of using external brokers like RabbitMQ or Kafka? So here we are deploying the application as a modular monolith, and we are tackling the communication between the modules in the application using this mechanism. But what if not only we want to process within this service, what if we want to publish information to some external systems? We are processing from our side, but maybe some other systems within our organization are also interested to process in whatever the way they are preferred. But right now we are not publishing that events. So we want to publish that also, right? So how do you handle that? So again, here you may just like after publishing it, like in order service, this is going to take care of publishing within the module, and then we can communicate, process them, and everything is fine. But what if I want to publish the same event to some external broker also, let's say Kafka or RabbitMQ or any other for that matter? So this is where you can write your custom code, like you can add Kafka dependency or RabbitMQ dependency, and then you can define Rabbit template and then publish the same event. But this is where Spring Modulith also make it a little bit simpler, where when we add this dependency, Spring Modulith events AMQP, which is nothing but for RabbitMQ. So we can publish an event here. We are publishing this event, and here I want to publish it not only for within the our system, but I also, whenever some event publisher publish this event, I also want to publish a copy of this event to this exchange with this routing key. So in this case, we are using RabbitMQ, but you can use Kafka also. So the goal is you specify, I want to publish it to bookstore exchange, RabbitMQ exchange, and this with this routing key. So this is where you have this externalized annotation to specify to what external system you also want to publish this one. Okay. If you don't have this annotation, it's all internal, like you just publish it and then other inventory and notifications are going to consume it. That's it. End of story. But you want to publish the same event to external brokers also. In addition to our internal system, you want to publish the same event to external. So that's when you can use this externalized annotation. So what we did in our config, we have this RabbitMQ configuration. And if you see, we have defined an exchange name and routing key, and then queue name, and then we defined a topic exchange with that name, and we have created a new order queue, and we bind this routing key with this queue name, and we also configured RabbitMQ to automatically convert the JSON event to JSON structure and publish it. So this is entirely related to RabbitMQ config. And with just this annotation, Spring Modulith figures out to publishing this event also. So earlier, when I configured here in Postgres, in addition to that, we have RabbitMQ also, right? So this is where we can see RabbitMQ GUI here. Let's So here I log in with guest and use. So here we have earlier we placed one order, and in addition to inventory and notifications, an event is also published to this queue, RabbitMQ. So here, let's see if we can pull the messages. So here, when I get the message, here I can see this is the order number, this is the product code, and like this. Okay. In the same way, if you want to publish to Kafka, you can just add Kafka dependency here instead of AMQP. You can publish Kafka, and then you can define Kafka related targets. So that is how you can communicate. I mean, if there is a need for you to publish the same events to some, because everything is internal, like all this inventory notification, that's all internal to our own system. But there could be reasons where some other systems within your organization also want to process that. Let's say notification service is not part of this application. Notification service is running as a separate microservice. And in that case, you just publish that as a event to RabbitMQ, and that microservice is going to listen to RabbitMQ, and then they send the email. So inventory is processed within the module. Notifications can be a separate microservice that consumes message from RabbitMQ and process it. So that is also possible. So it's kind of a simplifies if you want to publish the same events to external systems. Any questions?
So Shiva, how like what percentage of code we have reduced with the help of a Spring Modulith here?
So
because
here,
basically with respect to RabbitMQ, I'm talking about.
So here, this is common. I mean, RabbitMQ.
Yeah, this is common.
This is common. If you want to just explicitly configure this and then use that, that is common. But here, it's not entirely about the amount of code you reduced. It is about streamlining the process. Everywhere you don't want to write, okay, publish this to local and also to external system. So it's kind of a conceptual, like you are publishing an event, and not only the internal modules, you also want to publish it to external. So right now, you can simply inject Rabbit template here and then specify Rabbit template, publish so and so event. That is fine.
Additionally, we were binding the RabbitMQ template and we were configuring this. Right now, we don't want to configure that.
We don't have to.
Okay.
Because we are
so additionally, basically the invocation of that RabbitMQ template and all has been reduced.
Yes. So we don't have to explicitly do that. And also we can say we kind of reduce the tight coupling here. I mean, RabbitMQ configuration is there, but tomorrow, if you want to publish this to Kafka, You maybe configure Kafka related things, and you can specify Kafka topic, and that's it. Nowhere let's imagine if you use direct Rabbit template, and you may use in a bigger project in 100 different places. Now, if you want to change it, you need to change. But right now, with the same configuration, it just works.
Just we need to know the key template and the key to which we are publishing it.
Yes, yes. Yeah, right now I hard coded this, but you can also use spell expression and then externalize into property, things like that.
Externalize it, yeah. Perfect, sir. Thank you.
Shiva, does it use Spring Cloud Stream under the hood, or is it directly using Rabbit?
I think it uses Spring for RabbitMQ, not Spring Cloud Stream. But there is support. I mean, if you want to use streams, I think there is support. But right now, I don't think it is using.
And one more question. So basically, if an application is just a monolith app which doesn't interact with any other, then we don't need Rabbit kind of API at all.
Yeah, then you don't need to add the AMQP dependency. You don't need to use this annotation, and within your application, it just works fine.
Got it.
Okay, so one another thing is, go ahead. Yeah.
So generally in enterprise, we don't directly publish JSON to external systems, right? You will have some schema registry in between. So how do we configure that?
This is the default behavior, but if you want to have more control over it, there is a way where you can customize, you can use Jackson, and then you can define what is the customization process before publishing that JSON. But usually this is the default behavior, but in the documentation, you can find how to customize pre-processing before publishing that.
Register a converter like that.
Yeah. If you just go into this working with events, you can see how you can use different APIs, and then how to customize the event publication date, event serializer. So you can take a look at this.
Thank you. Makes sense.
And another thing is, so far we have seen the default module rules, but let's imagine you have some common utilities where you can have different packages and all, but you don't want to expose each module separately. Instead, common is like you have generic utilities where anybody can use any classes within that. So in that case, what you can do, you can make this as a open type module, which means any sub packages, anything you can use from any other module. It is open, and not only the top level ones, any nested code also can be used. So usually we need to be very cautious with this one, because this is the kind of a rabbit hole. If you start adding this open module for everything, then it's like you are kind of exposing everything in the package for everyone. The very purpose is to only expose the public API and make other things as private. So because this is just a utility package which just contains some common reusable things, not related to business module, that's why I make it as an open module. So that is one feature we have.
One question with curiosity I'm asking, like as we are publishing these events with the help of Modulith, right? So do we have, like when we are consuming is also like consuming also, do we have any capability with respect to this Modulith?
Here we are, okay. I mean, when you publish to RabbitMQ,
Yep.
So then that will be like a general process. I mean, general process in the sense we have a general approach. Like we have a RabbitMQ configuration, and usually how do you consume it? Rabbit listener. This is how
listener, and normally we'll write a listener and we'll get this, right?
Yes, okay. That's the process. Yeah.
So same way we can. So my question is, can we use a Spring Modulith also in that case?
We can use, that is also possible, but it is like, I mean, we can stick with one approach. Like if you don't want to leverage this event publication mechanism, if you directly want to use these brokers, Kafka or anything like that, then directly we can go for that one also. Yeah.
I think another way of asking that question is now we have Rabbit as well, right? So this listener, is it consuming from Rabbit and then invoking this, or it's skipping that?
No, this is not consuming RabbitMQ. Right now, these handlers are not consuming from the RabbitMQ.
Okay,
If you
this is
take a
what
look
we
at,
will do this way, right?
still the message is there in the queue. It is not yet consumed.
Okay,
So
when
these
that
are like, yeah, these are whatever we consumed, they are from this one.
correct.
They are stored in this table.
So that means if we add this module listener in another application, it's not gonna consume, right? We still
It's
need
not going to consume.
Git
Yeah,
listener or Spring.stream.
yeah, yeah.
Okay.
Okay, so we have seen this how we can publish events and how one module can depend on another, and if we try to use internal parts of it, how the test is going to fail that, and also it is going to detect if there is any cyclic dependencies across modules, right? So there is also one feature where it will automatically inspect module structure, and it is going to generate the documentation as well. So here we have simple documenter and write documentation. So what it will do, it is going to generate documentation. Here Spring Modulith docs, and here, so this is a PUML file, plant UML, and this is called a C4 model diagrams. So here it is kind of gives a picture of how your module dependencies look like. So here it says there is a common module, and your catalog module depends on common module, and there is customer module, and order module uses in the sense it is going to directly call API methods on this one. And here notifications listens to order module, because order module is publishing the order created event, and then these two are consuming them. So here they are saying listen to. So we are not creating, or we are not writing any of this code, just Spring Modulith is inspecting our code structure and automatically generating this documentation. Not only this plant UML, it also generates this ASCII doctor documentation, where it also identifies what are all the components are there. And then for each module, again, this is the whole application diagram here. And it also, per module, it will also say, okay, what is the module name and what kind of components are there, and what is the base package. And here, if we take a look at the customer package, again, this one, and it also identifies what are all the Spring components available. So this is the public interface, and this is the internal implementation. And similarly, catalog, and it also depends on common, and what are the public exposed APIs available. So like that, it also events listening to so and so events. So the good thing is, without writing any kind of code, with simple one line of code, you are able to generate the diagram of the live system. So usually we can say, how about we can write this one, right? But usually in the beginning of the application project, and then people draw diagrams, and then it evolves and nobody updates the diagrams. But here you are not writing diagrams, making diagrams explicitly. Looking at the current state of the application code, it is giving the real-time picture, how the actual code is and how the actual module dependencies is. And this is much more valuable. Like, it will never get obsolete, because it is projecting what is there currently now. It is not like, okay, 1 year ago we created these diagrams, but now things changed. It is like reflecting the current state of the code base.
So it is generating with the help of Modulith itself. Just any configuration we
Yes.
need, or just we added annotation itself.
So not the annotation, no annotation is required. Here we added the dependency to generate the documentation. So I think, yeah. So here I think as part of core or JDBC, it transitively pulls the docs module, and you have this line, just one line, no annotations,
It
no
depends.
nothing.
The document is designed based on the controllers or the service levels.
So these are Spring components. So here, if you take a look at it in the ASCII documentation, it is not specifying the controllers. It is only specifying the public exposed API. Here, our controller endpoints are not considered as a public API because nobody is going to call directly. Only public API is here in the customers, only the public API is customer service. This is a Spring Bean, right? I mean, though it is an interface, eventually it is going to implement this. So this is considered as the controller is not a public one. It is an internal part of the address module. So that's why if you take a look at this, here it says, what are the Spring services? And controllers are not mentioned, and what are the events it is listening to. So only the public API.
So any Spring application, just if they are using the service layers, we can build this doc.
Yes, but here one more thing is, if you have a service here, I mean here if you take a look at customer repository is also a Spring component, right? But it is not mentioned here. Why? Because it's an internal part of the system. It is not a publicly exposed API. So even if you have a at service with something like a customer preferences service or something like that, it is not going to be displayed here because it is inside the domain package, which is considered as a private part of it. Only the public one is rendered here, public API. So the idea is, let's say, I am working on inventory module. And somebody else is working on notification. So now when I look at what kind of a features orders module is providing, or what kind of features catalog module is providing, looking at this, I understand I have ability only to consume product service. I don't know about other internal details about what services are there, what repositories are there. I don't have access to that. Only the access I have is through product service. So that is the purpose of it. It is
explicitly we define it as a public services.
Yeah, publicly exposed API, we can say.
Publicly exposed APIs, okay. Through Spring Modulith.
Right, exactly. I mean, here there is no annotation specific to Spring Modulith. It's all Spring components only. Okay, to make it clear, inside this customer's domain package, let me create a customer preferences service. And let me make it as a Spring service, okay? Yeah. It is a Spring service, but it is also a public one, but it is there inside this domain, a nested package, which is nothing but a private to the catalog customers package. Now, if I run this modularity test, it is going to regenerate the documentation here. And now if I take a look at it, customers, right? So here it is only specifying customer service because this is a public one. And if I move this customer preferences to direct customers root package, now it became a public one, public exposed API. Any classes that are directly inside the module root package, and of course, if it is a public one, that is considered as a public API. Now, again, if I run this test and then verify customers.
So you say if it is a nested one, I am not considering it. If it is a high level one, you're saying?
Yes, anything that is nested is private part of that module. Only
Module.
direct descendant is this one.
Okay. Okay.
Okay, so far we had talked about the implementation part of it, communication and all that. But what about the testing part of it, right? We also tested the modularity of it. We verified whether everything is according to the Spring Modulith rules or not. Are we violating it or not? So these are the kind of checking the overall modularity of the application. What about the testing part of it? So usually when we write, let's say we want to write tests. Integration test. So we usually use at Spring Boot test, which is nothing but writing a integration test. When you use at Spring Boot test, it is going to load the entire application components, not just within the package or something like that. If you use at Spring Boot test, it is going to load all the components in your application. But one of the goal is you should be able to build your module as independently as possible. Not only building, you should also be able to test your specific module, only loading the components within that specific module and test your application. So instead of using at Spring Boot test, there is a new annotation provided by Spring Modulith, like application module test. And it also supports this web environment where you want to run web server on the random port. And here I am using test containers configuration to load the Postgres database, RabbitMQ and things like that. And when I start this test, what happens is it is not going to load the entire beans from catalog, config, customer inventory and everything. Instead, it is going to identify what is the package root. And this is the module root. This is the module. And it is going to load only the components inside this catalog module. By default, when you specify application module test, it is going to load only components from the catalog module. If you take a look at logs, we can see that. So here, if you take a look at the logs here. So in the console, it is printing, okay, we are loading the components only from catalog and large scale name, package, and what are all the Spring beans we need to load, exception handler, repository, product service implementation, product controller. So these are the only components it is loading. It is not loading anything from customers or anything else. So this way you are independently testing the module here. And this is common, like you are initializing some sample data and then you are making an API call and then you are asserting the data. This is kind of a standard. But the change is instead of using at Spring Boot test, which loads the entire application, you are using application module test, which loads only the current module. You are writing this test inside the catalog web controllers package, which means it is going to backtrack what is the module it needs to load. This is considered as the root package, right? And then this is the module we are talking about. So it is going to load all the components from catalog module. And similarly, if you take a look at, okay, let's say inventory, okay. Here again, same thing. If you run the test, it is going to only load the components from the inventory package. But the thing is, we don't have any API endpoints to test. We just have event listener, which is listening to event order created event and then processing it. Then how do we test it? So if you take a look at, it is only loading the components from inventory test. Okay. So the way we can test is we are using application module test, and then there is a feature called scenario where you can produce behavior where the entry point to this module is in inventory. We have a listener which is listening to this one. So with this scenario, what you can do, you can publish an event. Here I am creating a new order created event. with some random order number and then product code and things like that. And then I am waiting for 1 second of duration. And then I am waiting for, I'm checking, because once I publish that event, my expectation is for this product code of P100, which contains default 100 stock, and I placed an order with quantity 2, right? So what I'm doing is I am getting the stock level for that particular code, and then I am asserting the stock level now should be 98, because that is the behavior we have in our handler. So here, right now, P100 has 100 stock level. And then when you publish that event, it is reducing that stock level by whatever the quantity you placed. So that is the behavior. And again, we have a method here like a get stock level, right? So that is what we are testing. We get the stock level and asserting it. So if you have a module which only acts upon the events, you can use this scenario provided by Spring Modulith, and then you simulate that. You publish that event, and then you write the test, what are the test, and assert what you want to expect. Okay, this is another scenario. And even another scenario would be testing orders. So again, here we are using application module test. But if you remember, orders module is directly depending on customers module, catalog module. But we want to test in isolation where we don't want to load all other components. And this is what it does. It doesn't load other components. But our order service depends on product service and customer service, right? Our order service depends on product service and customer service. So that is why we are using a mock. We are using mock beans of those two dependencies. And Spring is going to take care of injecting these mocks into order service. And that's why in our setup also, we are setting up some mock behavior. If customer service get by ID is called with 1, just return this. If it is called by IDs of 1 to 3, return these customers. So typical mocking dependency, you define this, and then you make a call to API orders, and then you provide this payload, and you expect the status to be created. But this is working fine. But the thing is, in addition to getting the status code as 201 as a successful response, we are also publishing order created event to through application event publisher, right? So we also want to successfully assert that not only we got the response for HTTP API call, we also want to ensure this event is published. So this is where we can use this assertable publish events, again provided by Spring Modulith, and then you can assert that events contains this order created event, and you can also check within this event the customer ID should be 1 here, and also customer ID product code event product code should be this one. So not only APIs, when you publish some events, you can also assert that one. Okay, so now like we have the ability, like if you are publishing an event, outgoing events, we can assert like this. And if you are handling the events published by other modules, we can use a scenario like earlier we have seen, right? Scenario. So to simulate that behavior. So this is how you can test. And here, if you check, run this test, same way, like it is going to only load the components from orders. So okay, so okay, here we are loading only the beans from orders, and then we are direct module dependencies are there, but we are not loading them. These are the components we are using. Okay, but you can say this is fine. I am able to test independently this order module by mocking the directed dependencies. But what if I want to load the entire application and then test it? I don't want to mock this, but I just want to load like a complete integration test, not module specific one. So in that case, what you can do, instead of using Spring application module test, if you use Spring Boot test, okay, and you are not going to mark these two dependencies, because when you use Spring Boot test, it's also going to load entire application, and you don't want to mark any of these. So now if you run this, it is going to load the entire application context. So here it is kind of a loading entire thing, and maybe somewhere we are marking something. Okay, so when we are not using application module test, we may not be able to inject this acceptable published event. Okay, but that is the process if you want to load the entire thing. But now another challenge in the sense, another feature, you can say, I don't want to mark this. I want to use, I want to load catalog module. I want to load customers module also. Then what you can do, you can specify the mode. By default, it is standalone mode, which means whatever the module you are writing test in, it is going to load only the components from orders module. But if you want to load the dependencies also, direct dependencies, you can load that direct dependencies. Instead, if you just want to load all the modules, you can also load all the modules. So this way, you don't have to mark these. So if you take a look at what are all the components that are loaded, here you can see it is primarily trying to load orders, but also it is also including the dependencies, catalog, and customers also, because we specified not only the current module, load all the dependencies. Okay, so that's how you can test. If you want to load only the current module, you can mark it, or if you want to load the entire module set, you can specify it. So that is how you can test independently or together, depending with the other modules. Okay. So
normally we use in one question, Siva, sorry for that. Basically, if we use Spring Boot test, you're saying by default it loads all the configurations. Is that the case?
Right. If you use Spring Boot test, it is going to load everything.
Oh, so whatever the test cases I write, new classes I create and write for that particular service, also it loads everything.
Everything. So if your goal is to only test modules independently, then you should go for application module test. But if your goal is to load everything and test it, then you can go for. But once you go into this Spring Modulith route, this is the preferred approach. You want to test it in isolation, because if you go with the Spring Boot test, and then one of the goal is down the line, maybe you want to extract one of the module into a separate service, then it's like if it is a independent test loading only the module, it is kind of a relatively easy. You just move this to separate one. But now if you use Spring Boot test, it's kind of tying up with everything else again.
Okay. So it helps in picking up the server time also, if that is the case, right?
Exactly. It is going to load only the components from orders package or whichever the package you are writing. So it's kind of a relatively fast. It doesn't load the entire thing.
Okay. Great.
So these are all the features I wanted to talk about. So you have any questions on this one or in general? So, okay, let me finish a couple of things here. So the goal is like when you want to, I think we talked about the trade-offs. If you want to go for microservices, there are benefits and then there are challenges. But for your application, if you think I don't want those challenges, and the kind of challenges that brings by microservices is not worth the effort. Then you can start with Monolith, Spring Modular Monolith, and then you build all these features in a module strict modularization. And down the line, it is kind of a, just imagine, I want to extract catalog as a separate service. It's relatively easy, but because most of the code related to catalog is there in this package. Maybe you just extract that and a couple of properties. Compared to tying up with everything else, this is a much easier path to microservices. And enforce modularity, because this is an automated way. You don't have to sit and verify every time, am I violating anything, am I creating any circular dependencies? All that is tested in an automated way. So that is another thing. And also prefer async based communication if at all possible. First preference should be asynchronous. So that means reduce the coupling between modules as much as possible. And right now we take care of at the architectural level, but even within the modules, if you want to enforce some kind of a structure, you want to have certain naming conventions, or you want to use some specific dependency patterns and things like that, you can go ahead and use the arch unit. You want to fine grain any kind of architectural guidelines you want to enforce, you can use that also. Okay. So yeah, that's all. And so I have that application already published and is available on my GitHub. Let me ping that. You can chat.
Shiva, I have a question.
Yeah.
So this is not like microservices versus monolith, modular monolith, right? So within a Spring Boot application, whether it can be a regular monolith application or it can be Spring Boot application. So using this modular monolith, we should be able to define the boundaries for a specific module or across all these modules.
Perfect. Yes. So again, I mean, broadly, Spring Boot is not for monolith, Spring Boot is not for microservice. It depends on how you use. I can create a Spring Boot application, which is only dealing with the catalog service. Then I can call it a microservice. Or I can create a Spring Boot application like this, and I have multiple things, and I call it as a monolithic application. So as you rightly said, Spring Modulith is trying to make it as modular as possible when you are going with this monolithic architectural style, and then imposing the boundaries and properly enforcing the rules without having any circular dependencies and all that. So even if you are building a microservice, maybe even a microservice doesn't need to be like a one specific thing. Even a microservice can have a couple of modules in it. So still you can enforce that modularity.
Makes sense. Thank you.
And just Shiva, one question, a small question. So every integration classes must have the package name is the same, the original package name, or what?
Yes. So it is like it is going to identify based on the package name. It is going to identify what is the root module, and then try to load from there all the components. So I mean, even though it is a common standard practice, right? Like when you are writing test for a specific thing, you usually follow a similar thing and then write the test in a SRC test.
Okay.
Any other questions?
Shiva, I have a question. So in the very beginning, you discussed about a problem, right? That there is there was some product and there was some pricing, and you wanted to sort it out, right? And in the microservices, you have it in two different places, right? And they were in two separate databases. So in modular monolith also, we will be having separate databases, and those data will still be divided, right? So how do we solve that problem in this?
So here, I mean, still if you store, I mean, consider this. In day one, we decided we go with the different microservices, product service and promotion service. Then obviously you will choose a different data stores and then you go for a complete two separate service. But if you start with the modular monolith, and then you can have another package called promotions, and possibly you can store in the same database, but with a different schema. You may create, in addition to catalog, you may create promotion schema. But still, when you realize these are two, in promotions package, you talk to promotions table and get the data. But then you still have the ability to cross-join from different schemas and then get the data, right? You can join products table from the catalog schema, promotions table from promotion schema, and then you can define and get the data in a net price based. Compare that with the effort that is required to merge the data from two completely different microservices. So there you just have to. So the point is, if you start with modular monoliths, you most likely have in the same database, and then you can cross-join across schemas and get the data. But you realize that problem as soon as possible, you get into this use case. And the effort to merge these two modules is like, okay, you have two different packages and then you merge it and maybe you move the data to one table or something like that. Compare that with a complete microservice merge, that is huge thing. So this is where our understanding grows. Today we assume they make sense to separate them, but then you realize they are kind of tightly coupled. It makes sense to keep them together. So it gives you that gradual luxury of either you want to combine them, you want to split them. It's relatively easy in a single application than compared to multiple services.
Okay, got it. So effort of correcting that mistake is less in modular monolith as compared to merging two separate microservices itself. Okay, thanks for that.
Exactly.
So anybody else, any other question, any general question regarding today's session? Then this is time you can ask.
Yeah, I have one question. Like we have like separate like components here. So I'm thinking like, how does the deployment work here? Or is it it
will be a single application. Okay, am I sharing the screen?
Yes.
Okay, I'm sharing the screen. So though we have all these modules, at the end, it is a single Spring Boot application. And finally, you are going to get a single Spring Boot jar and you deploy it and run it as a single application. So from the deployment point of view, it's a simple monolithic application.
Okay. So in this case, I'm thinking like in the case of microservices, we can scale up the individual services, right? So I'm just thinking in this case, like how does the scaling work? That's what I'm thinking.
Yeah, we don't have that flexibility here. That is the goal. Like you start with modular monolith, and we assume like I mean that is a scenario where in real complex applications you need that kind of a scalability, but not all the applications need that kind of independently scalable things. And in that case, you build a modular monolith, and then you have all the benefits of a simple deployment and everything. And then, as you asked, like, okay, we start with this one. We identified we are getting too much of traffic for catalog. You extract it as a microservice and let the all other things still continue this one. So this is the path to microservice. If you don't need those facilities of independent scalability, you happily continue with a single application process and it works fine. But then when you reach to a point where, no, I want a specific module to scale out, you just extract that. And that is a much simpler process. Like you already keep it as a modular fashion. You can extract that and then you scale it up. But with a modular monolith, you still run as a single application and you cannot scale independently each module.
Okay, thank you.
And this is another practice I learned because if you think, okay, we organize the code in different things, but still put all the tables in a single schema. Unknowingly, you kind of start creating the references to other tables. For example, here, when we go for orders table, create orders table. Where is this? So here, if you notice customer ID, maybe this is wrong here. We do not have a foreign key to customers table in the customer schema. Though we are talking to in the same database, it is important to treat as if they are completely different microservices or different data stores. But if you kind of make these as a foreign keys and all, again, you are coupling that at the database level. So you need to think each module has its own database, though it is all still in the same database, but with a different schema. You need to take care of not to link different tables from different modules, so that if you want to extract this into a separate service, now you don't break anything else. But if you make this as a foreign key referencing to customers table, then you are coupling at the database level. Though the code is modularized, your database is coupled. So one of the thing to take care is that's what if you think about, can I extract any module as a microservice? Then you get all these things. Now, when I think of extracting this, not only code, the database also I can extract because I don't have tie-up with other tables.
One quick thing. So usually the data integrity is being maintained by the database, right? So
right.
What are the things we have discussed so far, that is just to maintain the modules and all from the code perspective. But data integrity is also important, right?
So yeah, that is the compromise we need to think about. Just imagine we are building a microservice architecture. How do you do it? In microservice, you don't have foreign key to a table to a completely different services database, right?
But let's say at the end, if it is the same database, then nothing is stopping us.
I mean, just think in the other way around. We are building a microservices, not this modular monolith. And catalog service is a separate microservice. Customers is a microservice. Orders is a microservice. There you won't have. You include that validity and everything in the code, right? In the microservices. Here, when you take a look at order service, here we are verifying whether it is created by valid customer, or whether here we are validating by calling product service is the code, product code is a valid one or not. So we are kind of compromising here with the ability to keep them separated. So that is one thing.
Okay.
So when it comes to architecture, be it modular monolith or microservices or event-driven everything, all are like they give some flexibility and benefits, and they also impose some trade-offs. We need to understand, okay, what happens if I want to make sure that it is integrity is more important, and I make it as a references customers of ID. What is the trade-off? I ensure that no invalid customer ID is inserted into the orders table. That's a plus. But what is the trade-off? When I want to move orders into its own microservice, or when I want to move customers into its own microservice, then I have a problem, right? So you need to think about these trade-offs, and then the best bet is anyway I do the validation, so I don't tie up these tables from different modules.
I think it's talking about the pattern where there are multiple microservices sharing the same database, but then you restrict your scaling at database level, right?
So first thing is sharing the same database from multiple database is not a good practice, but people go for it as a step towards the microservice. Let's say they already have a monolithic application and they want to go for microservices. So on day one, you cannot simply separate out everything. So what they do, okay, let's use the same database for now, and then you first separate out the code into different services and still continue to talk to database, same database. But gradually you kind of separate it out. But using the same database from multiple services is not a good practice. Because you do not have a ownership then, because you can assume the other service is doing the validation of something, but they might not do it, or you put whatever the data you want to. So it is not a recommended practice, sharing the same database from multiple microservices.
Plus also
It's
now
only
you have reached your scaling at that database level, right?
exactly
One database, so it cannot scale beyond that database's instance type.
right. Yeah.
Shiva, is there a general practice having a separate databases for each microservice?
It's a highly recommended practice. The only use case where you use the same database from multiple microservices is when you are in the migration stage where you have a monolithic application and you want to go for microservices architecture. That is when you start with using same database, but gradually each service should have. I would highly recommend, if you are interested in microservices thing, microservices.io. So here they mention, so somewhere they have a table database. So so I would say just take a look at this one, and exactly they talk about when it is okay to go with the same database, when it is not okay to use the same database. I highly recommend.
Okay, so November 23, so Java Fest event is coming. So it's the second edition of the event. And so it will be happening at Infosys Bangalore. And there are some really good keynote sessions are going to be there in regards with the Java tech stack. And GUJs all over the India, they are all supporting the event. And this is one of the great opportunity for you if you're a Java developer, and if you want to know more about what's happening inside the world of Java, then this is one of the events you should not miss. Okay, it's a totally community driven event, and in order to get more detailed about this event, you have to head over to this website javafest.org, where all the details are mentioned and what are the sessions and what are the speakers are there. And you can also book your tickets on for that particular event. And so I would request everybody to go over to this website and check out, and please join us in big numbers there. It was a great time with you, Shiva. Thank you so much for giving us your valuable time and sharing us such an in-depth session. I was not expecting the session to be such an in-depth, and it was a really great session. I learned a lot from it, and we all learned from it, I'm sure. And there were some really interesting questions came up, and you like answered everything in a very smooth way and in a very beginner friendly way. And looking forward to invite you in our future sessions as well. And we have a lot of things to talk about, and I think it will add a great value to our whole audience.